In this video, we're going to finally start using right triangle trigonometry to actually solve for some values in problems. So we're going to actually find the sides in triangles. If you recall from my previous set of videos, the very first example we dealt with was this right here. And it said find the value of x in the triangle below. And so I see that since I have two sides and an acute angle in a right triangle, but I don't have this third side, I cannot do a squared plus b squared equals c squared. That would not work. What I can do is label my sides. So across from the right angle is the hypotenuse. Across from this angle is the opposite. This side here is the adjacent. I see that I have the hypotenuse and the opposite, and I can use my mnemonic device, so ka toa, to set up the problem. So I'm looking for O and H. This one has the O and the H. So I'll get the sine of 40 degrees is equal to opposite over hypotenuse, so x over 10. But now what? Okay, so we're going to actually figure out how to solve this. So solving for sides using trigonometry. The first thing I'm going to do is set up the trig ratio. And I'll use ka toa to find the appropriate trig ratio. In our example here, it happened to be sine. The second thing I'm going to do is I'm going to use a calculator to approximate the trig value. Now let me go to my calculator. You have to be a little careful here. So this should be set up correctly. I can check by trying the sine of 30. So let me put that in. This is important. So check that the sine of 30 degrees should give you 0.5 or should give you 1/2. So when I type in, I'll type in 30, press the sine button, and I get 0.5. Mine's set up correctly. If you don't do this, so if this doesn't work, you can make sure that you are in degrees, not radians. Radians are super important as you get further on in high school and towards college mathematics, but for these problems, you will probably see them as degrees. So make sure you're in degrees for all the problems we're doing here. Once I use my calculator to approximate the value, then I'm going to solve the equation. Now there's a couple ways. I'll show you a couple ways, but I am going to, for my examples, use a proportion. It just makes things easier. Not faster, not better, just easier. So let's get back to the problem that we had. So in this one, I can see that I have the hypotenuse and I have the opposite. We've already done that work. So hypotenuse, opposite. That means from ka toa, I'm looking at the sine, that's the opposite hypotenuse. So I will take the sine of 40 degrees will equal the opposite over the hypotenuse, x over 10. I'll go to my calculator and I'll do the sine of 40 degrees and get 0.64279. It is important, even though I'm going to round it to 3 decimal places, it's important that for now I leave 5 decimal places or some extra information here. I'll talk about why shortly. I bring down the rest of my equation. So all I did is I used the calculator to figure out this value. Now, there are a couple of options, but I'll show you what's probably the simplest in general cases. I can put a 1 under this and cross multiply. So I will get 10 times this. So I go and do times 10. That will give me 6.4279 equals 1 times x, which is 1x. And I'll divide both sides by 1. Many of you can probably see it already, but I will get that x is approximately 6.428. Now, I said it's important that I leave some extra information just because I get something called round off error. It would only change this last digit here, but if I round too soon, it could mess that up. Okay, all the problems pretty much work the same way. Sometimes the equation can be a little bit different. I do want to point out for some of you that I could have in this equation multiplied both sides by 10 and gotten straight to this answer. If that makes sense to you, feel free to do it. But let's see 2 more examples here just to make sure we've got the idea correct. So find x in the triangle below. We'll go through and label some sides. So I notice that we have the hypotenuse. I don't have anything on the opposite leg, but I do have something on the adjacent leg. So I'm looking for h and a. The one with h and a in it is this ka. So we'll get the cosine of my angle, 63 degrees. The angle always goes in here. Is equal to adjacent over hypotenuse. So that's going to be 11 over x. I'll go to my calculator to find the cosine of 63 degrees. And I'll get 0.45399. Now, this is why I like setting up the proportion. In this problem, yeah, I could just multiply by 10 because I was dividing by 10. But for this problem here, the x is at the bottom. And I can't finish solving by just multiplying by x. There are other ways to do it, but most people find it simplest to just put the 1 under here and cross multiply. And you'll get 0.45399x equals 11. And now I can just divide by 0.45399. Go to my calculator. So 11 divided by 0.45399. And I get about 24.2296. So x is about 24.2296. If I were rounding to 3 decimal places, that would be 24.230 because the 6 would round up to 9, the 9 would go up to a 10, so we get up to this 30. Just a little bit of rounding review. Okay, one more example. Find the value of x in the triangle below. Same process. Okay, that's one of the nice things, that it's in some ways tricky to start off, but once you've got it, it just keeps going. So in here, I'll label my sides. Notice I don't have the hypotenuse marked, but I do have the opposite leg and the adjacent leg marked. So ka, toa, I am looking for O and A. That would be toa. And now I'll write it out. Tangent of my angle is 49 degrees, equals opposite over adjacent. The opposite is x, the adjacent is 22. Run over to my calculator and find the tangent of 49 degrees. I get 1.15037. So 1.15037 equals x over 22. And I will set up the proportion and cross multiply. So I will get this times 22 times 22 will give me 25.308 equals, I guess it's approximately, 1x. Divide both sides by 1, and I will get that x is approximately 25.308. If you have any questions, I'll have a video with 6 more worked out problems in the description down below.